timer's not going yet. I have, this is like an 8-minute talk. I need to know where I'm timing it so I can speed it up if need be. All right, so hello, my name is Adele Balmer. I'm a PhD student in Derek Johnson's Population Ecology Lab and Leslie Bolwick's Avian Ecology Lab. And today I want to talk to you about my interest in doing parental care and trade-off juvenile recruitment experiments, which is still a branch of my overall goal of studying population demography. And so the reason for this is, as a lot of you already know, we're entering into the 6th mass extinction events. So unfortunately, unlike the other 5 previous mass extinction events, this one is going to be human caused. And so the good side of it is that there are people out there who are trying to slow this down, and they're doing it through things like management strategies. However, for a management strategy to actually work and be successful, they need to understand the life histories of these organisms that they're trying to make these management studies for. So a life history, the patterns are really evolved through natural selection. So it's this optimization between these trade-offs between growth, survival, and reproduction. So what I'm interested in is the trade-off between survival and reproduction in migratory songbirds. So my species I'm going to be working with, it's going to be a model species for migratory songbirds, is the prothonotary warbler. So the prothonotary warbler is a neotropical migratory songbird. It's also considered an indicator species for forested wetland areas. And the really cool thing about them is that recent studies have shown that they can double brood. So what this means is after they fledge one nest, and there's a little more time before they actually have to migrate, they decide to lay another clutch. So they do that second brood. So this in turn actually doubles the reproductive success for that breeding season, which sounds great, right? Why doesn't everybody just double brood and double the reproductive success? Well, the problem is that there's this trade-off. So when that second nest is, when they're nestlings and they're trying to grow and get big to be able to fledge, the parents are also at that time trying to store energy to be able to make migration. So these birds, their breeding area is this red area in the United States, and then they're going to migrate all the way down as far south as South America. That's a really long way for a very small bird to fly, especially when they're trying to fly over the Gulf. That's a lot of area that there's not going to be a lot of food for them. So they have to make energy storage to be able to make that distance. And the problem is when they're feeding that second brood, that's going to overlap with that time when they're trying to store their energy. So they have that trade-off. In other birds, in other migratory songbirds, research has shown that that second brood doesn't have as strong of juvenile recruitment as the first brood. So juvenile recruitment is how many birds actually make it back from migration. So that first year of survival. So they're finding that that first year of survival for the first brood is more successful than second broods. So even though they're laying the same number of eggs as first and second brood, not as many are surviving. And I want to know why. So does parental care influence second brood juvenile recruitment in a migratory bird? So the way that I'm going to do this is I'm working with the engineering department right now, and we're creating these RFIDs, so this radio frequency indicator transponder. And so these, it looks like this isn't the exact one. This was actually for a bluebird study, but it's going to look a lot like this, and we're going to put it on our nest boxes. The birds are going to have these pit tags that are going to be strapped to their legs. So the tags, if you've ever had your animal have a pit tag where you can take a reader if they get lost and they know who they are. So it's the exact same technology, but instead of injecting it into the bird, which other studies have done, we're just going to put it on one of their leg bands. We found that it doesn't affect them at all, so it's less invasive. So we're going to, when we capture them, we're going to put these leg bands on, and we actually did that all last summer. And so next summer, we're going to put these RFIDs onto the nest boxes, and so every time a parent comes in and out of the nest box, we're going to know that. So my hypothesis is that the first brood is going to have more parental care, more visits from the parents than the second brood. Because during that second time, the parents, they're not going to share all their food like they did for the first brood. So it's going to end up, my hypothesis is that it's going to affect how many of those fledglings are going to make it back from migration because they didn't have as much parental care as the first brood. So the cool thing about this is we can compare between first and second brood, and we can also compare between 2 second broods. So we can look at 2 neighbors who both had second broods and see if one of them provides more parental care, and if so, do their offspring have a better chance of making it through the first year? Do they have a better chance of surviving migration? Because there is this trade-off. If they're spending more time with their offspring, then they're spending less time and energy storage on themselves. So I'm going to look at all of this with precombinatory warblers in hopes to better understand the life history of migratory birds. Nice watching at me. So, any questions?